Hi again. In this lecture, we'll understand how do we store a file in HDFS, because we have understood HDFS is the storage layer of Hadoop ecosystem. We really need to know how exactly the file is stored in HDFS. Let's get started. Assuming that you have a very large text file. So if we were to store this particular file in HDFS, what exactly happens? How it is stored? As we know, for the sake of this discussion, understand that this particular file is of 1 GB file size. We want to store this as a part of the HDFS. The moment we want to store a file as a part of the HDFS, as we know, we get the partitions into picture or the blocks into picture. What do I mean by that is the data is not stored at only one system in HDFS. Data is distributed. In order to make that happen, what exactly is done is the whole large file is split into smaller chunks, which are also called as blocks. Big file is broken into or split into smaller chunks called as a blocks. Assuming that you have a file size of 1 GB. Now, if you see here, what we have done is 1 GB file has been broken down into 8 blocks, which are also called as partitions in this case. We have already understood in the previous slide that any file would be broken down into smaller chunks or blocks, except that we are saying we are breaking down this into the block size of 128 MB. So why are we breaking down this into 128 MB? We'll see that. Apart from that, we also store the different length files in a same way. Whatever may be the length of your file, it may be 1 GB, 2 GB, 1.5 GB, 500 MB, or 1 TB, it doesn't matter. All of them are treated in the same way. What is that? We'll try to understand. Let us drill down more into the block size of 128 MB. As I said, any file for that matter which need to be stored in HDFS need to be broken down or split into smaller chunks, which are also called as blocks. And we are saying they are broken down into smallest size of 128 MB. 128 MB is the default block size of Hadoop 3.4. Whenever you want to store a particular file in HDFS in Hadoop 3.4, that particular file would be split into 128 MB smaller chunks. But why is that we need to have 128 MB only? What we understand is if we have more size, it may be 256 MB or less size, the seeking time, when I say seeking means, if you know this is a disk. In the disk, the data is written like this in a fragments, all these like this. This is the pointer which has to go and locate the data, and it has to spot the data and read the data from there. Whatever the data which we need, which is stored, it will not be found just like that. It has to go and seek. If we have to seek a particular data, because the data is partitioned, the data is split into smaller chunks. If you have to go and locate it, it seems if you store the data in a blocks of 128 MB, the time taken to seek the data on a disk is optimized or it is minimized, it seems. That is the reason they have done some experiments and some analysis, and they have gone for 128 MB as the default block size of Hadoop 3.4. Whenever you store any kind of a file, that will be broken down into smaller chunks of 128 MB. Now that we understood the default block size, that is 128 MB, assuming that we have different length files. How the split happens, how it is stored. Let us try to look at that. This is a 1 GB file, and as we know, default block size is 128 MB. Because the default block size is 128 MB, if you just divide 1024 MB by 128 MB, you'll get 8 blocks. A file size of 1 GB is divided into 8 blocks because the default block size is 128 MB. Now let us try to see how a file of size 500 MB is stored. As I said, whether it is a 1 GB or a 500 MB or it may be 2 GB, the file would be treated same way. Means whether it is a 500 MB or 1 GB, number of blocks would be this 500 MB divided by 128 MB. That means we'll get a 4 blocks, and 3 of the blocks would be of 128 MB and the fourth block would be of 116 MB. Whether you have 1 GB or 500 MB, split would happen same way. Just because file size is less, it will not go for a 64 MB splits or blocks. It will go for only 128 MB. This also would be broken down or split into a block size of 128 MB. In this case, we may get couple of more. For zero point 0.5 GB, we get 4 more blocks. When we say the files of different lengths are treated the same way, this is what we are referring to, whether it is a 1 GB or 500 MB or 1.5 GB, whatever the file sizes you want to store in HDFS, all of them are broken down into smaller chunks of 128 MB each, immaterial of what is the size of the file which you want to store in HDFS. We understood what are the different ways to store the data. I mean, for example, when you want to store a file, how it is broken down into smaller pieces and it is stored in a different data nodes. Now that we understood the default block size of a Hadoop 3.0 is 128 MB, let us try to understand what happens if we increase the block size, what happens if we decrease the block size. In a way, it is a block size trade-off. How do we really optimize this block size? If you increase size of a block, it reduces the parallelism. If you decrease the size of the block, it increases the overhead. We'll see how it is going to happen. In this case, let us take an example. We have block size of 128 MB and we do have a file size of 1 GB. Let us keep the file size intact, means we want to store only the 1 GB of file, and if we increase the block size from 128 MB to 256 MB, what happens? You can just pause the video for a moment and see what exactly happens. We'll get 4 blocks here. Instead of getting 8 blocks, we are getting a 4 blocks. What does it mean? As we know, as a part of the distributed processing happens on each of the blocks. Since the number of blocks have been reduced from 8 to 4, here distributed processing happens on 8 blocks, but here distributed processing happens on the 4 blocks. When you increase the block size from 128 MB to 256 MB, it is decreasing the parallelism, it is reducing the parallelism. On the other way, if you go ahead and decrease the block size from 128 MB to 64 MB, what exactly happens? Can you pause the video and just think of what happens here is, for the same file size, we'll get so many blocks. Means we have 8 blocks here when we have a default block size of 128 MB. If you reduce the block size from 128 MB to 64 MB, what is happening is the number of blocks are doubling. In a way, it is increasing the parallelism, but at the same time, it is increasing the overhead also. When we say it is increasing the overhead on the name node, as we know, the name node is storing the block locations. It stores the metadata of file, right? Block size. When we decrease the block size, it increases the parallelism. At the same time, it increases the overhead. So then what should be the optimal block size? Optimal block size as per the Hadoop 3.0 is 128 MB. But still, depending on your project, you have to decide what is the optimal block size for your project. Now that we understood how the block size need to be decided, let us try to understand how exactly this split data is stored in different data nodes. As a part of the distributed storage, the data wouldn't be at one place. Then where will be the data? The data will be distributed across different systems. We also understood as a part of this lecture, a particular system is also called as a node. In this case, we are talking about the data nodes. We also understood data node is the one which is physically storing the data, assuming that we have a file size of 1 GB. Now this file size is split into 8 blocks based on the default block size of 128 MB. How exactly the data is stored? As we know, HDFS supports the distributed storage. So we are talking about the distributed storage here. So 1 GB of data, which is split into 8 blocks, would be stored as a part of 4 data nodes. This is another representation. What we want to show here is how the data will be distributed. It is not necessary that all the blocks may get into one particular data. It's not necessary. So whenever we have a 4 data nodes are nothing but as systems. If we have a 1 GB of file size which is split into 8 blocks, how exactly the data will be stored? If you see, first 2 blocks would go and sit in data node 1. When I say data node 1, we are talking about a system 1. And third and fourth block would go and sit in data node 2. That means it will be distributed to the data node 2. Fifth and sixth block would be distributed to the data node 3. Seventh and eighth block would be distributed to the data node 4. So like this, whatever may be the amount of data you have, that would be split into smaller chunks of 128 MB size, and those blocks would be distributed across the data nodes available in a cluster. It depends on how many data nodes you have. You may have 1000, you may have 2000, you may have 500. So it depends on the project you are involved in. This is how the distribution of the blocks would happen to the data nodes. As we understood, name node, what does it? Stores the metadata of the file. For example, this block 1 is of file 1 because we are dealing with only one file here. File 1 belongs to the block 1. This block 1 is stored as a part of data node 1. And the block 2 is also there as a part of the data node 1 only. So like this, name node would consist of the address of all the blocks in the data node. Why it is so important? We'll see that as a part of the upcoming classes. But as a part of this lecture, what you need to understand is data is spread across the different data nodes which are connected by a network, and name node consists of the address of the blocks which are there in a data node. Thank you very much. You have a wonderful time.